Everyone, myself Ganavi from the Department of Computer Science and Engineering. Today's topic is about object database extensions to SQL. Introduction to object database extensions to SQL. The object database extensions to SQL provides a way to store and manage complex structured data within relational database system. This allows developers to integrate object-oriented programming models and data types with the power and scalability of the SQL databases. Motivation for the object database extensions. Complex data structures. It is a traditional SQL database struggle to efficiently store and query the complex nested data structures common in modern applications. Object-oriented design. The object database extensions enables a more seamless integration between the object-oriented programming model and the underlying data storage. Performance optimization. Storing data in its native object form can improve query performance and reduce the need for complex object relational mapping layers. Key concepts and terminologies. Object data type. The custom data type that encapsulate complex structures, including attributes and the methods. Object inheritance, the ability to define subclasses that inherits properties and behavior from the parent classes. Object identity is a unique identifier for each object independent of its attribute values. Object reference. The object references are the pointers that allows objects to reference and navigate to other related objects. Object relational mapping frameworks. The OMR frameworks provides a layer between object-oriented code and the relational databases, allowing developers to work with the data in a more natural object-oriented way. Popular ORM tools example includes Hibernate, Django, ORM, and SQL A1, which simplifies database interactions and handle the object relational mapping automatically. Limitations. The ORM frameworks can introduce complexity and performance overhead by making the object database extensions a valuable alternate for certain use cases. SQL extensions for object-oriented programming. Object data types. The SQL extensions allows defining custom object types with the attributes and methods similar to classes in the object-oriented programming. Object inheritance. The subclasses can inherit the properties and behavior from parent object types by enabling more flexible and modular data models. Object queries. The SQL can be extended with the object-oriented queries capabilities such as navigating object reference and invoking the methods on the objects. Advantages of object database extensions. Efficiency. Improved query performance and reduced complexity compared to the ORM solutions. Flexibility. It is the ability to model complex hierarchical data structures that are difficult to represent in traditional relational schemas. Scalability. The object database extensions can the scalability and reliability of underlining the SQL databases. Developer productivity. It is closer alignment to between the object-oriented programming models and the underlying data storage. Challenges and limitations in SQL. Vendor lock-in. It is the object database extensions were typically specific to a particular database vendor, limiting probability and the migration options. Complexity. Introducing the object-oriented concepts can add complexity to the database design and the management. Legacy integration. It is the integrating object database extensions with existing relational systems and the application can be challenging. Encapsulation and data hiding. First, the object database supports encapsulation to hide implementation details. Then the data hiding improves data security and integration. At the last, the objects enforces access control through methods and the attributes. Complexity relationships. The object database extensions are typically specific to a particular database vendors, where the object database supports complex relationships between the objects. Relationships can be defined using the object reference. Queries can be navigated through the object relationships efficiently, limiting probability and the migration options. Versioning and the concurrency control. The database offer built-in versioning and the concurrency control mechanism. The versioning allows for tracking changes to the objects over time, and the concurrency controls ensures the data consistency in multi-user environments. Performance and optimization. Object databases optimize the performance through the direct object access. Indexing and caching mechanism improves query performance, and the object-oriented design patterns can be leveraged for efficiency data retrieval. Scalability and extensibility. Object databases are scalable and extensible to accommodate growing data needs. New data types and relationships can be easily added without disrupting the existing data. The object database schemas can evolve with changing the business requirements. Use cases of object database extensions. The object databases are used in applications requiring complex data structures. Industries like finance, healthcare, and IoT benefits from object database extensions. Applications with large interconnected datasets can leverage object oriented modeling. Database modeling best practices. The proper database modeling is a crucial for efficient object database usage. The normalization principles applies to object database to reduce the redundancy, and the object-oriented design partners can guide the effective data modeling. Real-time data processing. The database extension supports real-time data processing. The streaming data can be stored and processed efficiently. The complex event processing can be implemented using object database features. Compliance and regularity requirements. Object databases helps organization compile with the data privacy regulations. Compliances with industry standards like GDPR can be facilitated by object database features. Conclusion and future directions. Continued evolution, where the object database extensions are accepted to evolve with more advanced features and a tighter integration with object-oriented programming language. Hybrid approaches are the combining object database extensions with traditional relational database or no SQL solution may be provided the best of both worlds. Adaptation challenges. Overcoming vendor lock-in, complexity, and legacy integration issues will be key to wider adaptation of object database extensions. Thank you.